right, guys. This is almost the last part of the notes for our Unit 1 that we were taking. This is going to be section 1.10, talking about the real numbers. So this is kind of weird, but, just really explaining what some of these numbers are and where they belong. Okay, so first off, the real numbers, and I'm going to type because my handwriting is super trashy. So, use purple, what the heck? It might be a little big. So the real numbers are the set of numbers which contains all rational and irrational numbers. So all of the numbers that we talk about, all of the numbers that you're going to talk about in math for the rest of your high school career are all going to be real numbers. You don't really get into imaginary numbers until Algebra 2, but that's only if you're getting advanced. But, all of the sets are real numbers. And we go down the line and we want to talk about what's an irrational number. An irrational number has a decimal that never terminates, right? It doesn't end. It's a decimal that goes on forever. Why is this so large? So it never terminates. Okay, that just means it goes on forever, and it has no repetition. Okay, so it doesn't terminate and it doesn't repeat. I can't spell. So yeah, my handwriting looks better when I'm typing, but I still can't spell. It doesn't help me. Okay, so never terminates, that means doesn't end, and no repetition, that means it doesn't repeat. Okay, so if you want to put in doesn't end, fine, and doesn't repeat, that's okay. All right, here are some examples of irrational numbers, right? If you took your calculator and you put in the square root of 3, I guess it would help if I was writing. That thing's going to be bananas. It's going to go on forever, and it's not going to have any repeaters, and it's not going to terminate. It just goes on forever and ever. Yeah, like 1.732050808. That's all that fits on my screen, but it does continue. It's ridiculous. Another irrational number you might be familiar with is pi. Right? This is pi. 3.14 blah, 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 a million trillion digits later. I do not know them all. All right? Also the square root of 5. And the square root of 41. These are just some examples, mind you. There are many irrational numbers out there, but they're crazy. They're irrational. They have decimals that don't terminate, and they do not repeat. Now let's talk about rational numbers. This is something that we're all a little more familiar with. They have decimals that do terminate, okay? So the decimals do end. Or they have repetition, or they repeat themselves over and over and over again. All right, here are some examples of some rational numbers. How about 5/7? Right, we talked about fractions, it's just division. If I take 5 divided by 7, I get 0.71425285714, and then it just keeps going. It stops at 3 because it rounded up, but it does repeat. That one might be a little tricky when you first take a glance, and you might assume it's irrational. Make sure you're really looking at those digits. 3 is a totally rational number. Like, that's a normal number. -1 is rational. 20/5, which is just 4, but 20/5 is rational. The square root of 16 is rational, right? That's just 4. 0, that's rational. 2/3, that's rational. Okay, those are all rational numbers. All right, so classify the rational numbers even farther. Okay, so these are all under the rational number umbrella. Integers, remember that's positive and negative whole numbers. So if I have my ... and we start with, like, let's say -3, -2, -1, 0, 1, 2, 3, dot, 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 little curly bracket here, because it's just going on forever. They go on forever in either direction, but there's no decimals, positive, negatives, and 0. Then when we think about whole numbers, that has no negatives. It starts with 0 and goes up. 1, 2, 3, 4, dot, 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 goes on forever in the other direction. No negatives. Maybe you want to write yourself a little note. No negatives with whole numbers. Then you have natural numbers, just another step down from a whole number. It doesn't include 0. Natural numbers start with 1, 2, 3, 4, and then they continue on, dot, 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 forever. Okay? So integers, negatives, positives, and 0. Whole numbers, positives and 0. Natural numbers, positive numbers. Easy peasy, lemon squeezy. Okay? Now what we're going to do is we're going to fill out this little Venn diagram we got at the bottom of your paper. All right, looks kind of crazy, but what we're going to do is we're going to first decipher this big rectangle that all my little circles are in. That's going to be the real numbers. So these are all real numbers. Then we have this little freak over here, this bubble that's not connected to anything over here. This is going to be the irrational. Irrational numbers. Okay, then we're going to deal with all these circles. Okay, so let's talk about the biggest circle. So the biggest circle here, right, this is irrational. The biggest circle over here is going to be rational numbers. Then underneath rational numbers will be integers. Remember, that's positive, negative, and 0. Then below integers will be whole numbers. Remember, that's 0 and positive. Whole numbers. And then the last little one is going to be our natural numbers. Okay, that's only positives, no zeros, no negatives. So these are natural numbers. Think about stuff that you can see in nature. And I know somebody over there is probably being a smarty and it's like, I can see nothing, and nothing is 0. But open your eyes, okay? It's stuff that you actually see. Don't be a smarty. Natural numbers. And I'm sorry, my handwriting just got worse as this went along, but I said the word. This is natural. Just my T made that look weird. Okay? So just a little quick visual reminder or a way like to really see how they're all related, right? In this big rectangle, they're all real. So all of these numbers are real. Then we have our little freaks here that are not related to these guys. And that's how we do it, all right? All right, let's look at some examples and see if we can classify these numbers. All right, so first off, negative 47. First off, let's first off say all of these are going to be real. So you can write real with all of them. We know it's real. I know it's rational because once you go real, then you go to the next, like we go back to this bubble, right? We know it's in the rectangle. Is it irrational or rational? That's the question you ask yourself. If it's irrational, you're done. It's real and irrational. If it's rational, then you're like, is it an integer? Is it a whole number? Is it a natural number? Okay, that's how we're going to do this. So we know it's rational. Now we go down our little bubble, right? Is it an integer? Yeah, it's negative. Is it a whole number? No, because it's negative, so we're done. So this number is real, rational, integer. Boom. All right, 2 3/8. I don't really know what I'm talking about. I need to put this in decimal form. So I'm going to do that. 2 3/8. What? My calculator is not giving me the right number. Hang on a second. All right, sorry, I had to get the regular calculator and use the ABC button. So 2 3/8 is 2.375, okay? So you want to make sure that you're turning it into a decimal if you have a fraction, so you can see if it terminates or repeats. So 2.375 does terminate, right? It only goes 3 digits out. So let us begin. First off, we know it's real. It's also rational because it terminates. Now, we go down the list. Is it an integer? No, because it's the decimal, silly, so it's only real and rational. And that rational really is making me, I don't like the way that looks. I'm so sorry, guys. Better. Okay, let's look at number 3, the absolute value of -9. Well, remember, absolute value is the measure of distance from 0 on a number line. So the absolute value of -9 is positive 9. Now let's go down our list. Well, we already know it's real. All right, and we definitely know it's rational. All right, we're going down the list. Is it an integer? Yes, it is. It's an integer. Is it a whole number? Well, yeah, it's positive. And is it natural? Yes, I can see 9 geese flying in the sky. I mean, not right now, but you know, I'm just giving an example. It's natural. All right, so it's got it all going on. Nice. All right. Moving on, look at number 4. Square root of 23. Well, I got to plug that in because I don't know what that is. That is 4.79583153. A 3 repeated, but it didn't, the 7 and 9 did not repeat. So this is crazy number that I believe doesn't repeat and doesn't terminate. 4.795831. I'm only writing this out this one time. I'm not doing this again. This is crazy, okay? So, ... That's all my calculator would display on the screen. So, first off, we know, because I told you, all these numbers are real. Now, this one is a freak. So, it's irrational. It's real and irrational. Perfect. All right. Because once it's irrational, there's nothing else to ask yourself. That's it. It's real, irrational. All right, this number for number 5 says 1.5625. It terminates. So it's definitely rational. So let's start with real, right? It's real. It's rational. Is it an integer? No, because it's a decimal, so we're done. It's real, rational. Done. Okay, moving on. Last one in this set here. 0. Well, 0 is a real number. It's also rational. Just started writing really big for some reason. I'm not sure why. And then we go down our list. Okay, underneath rational is integer. Is 0 an integer? Yeah, sure, why not? Is 0 a whole number? Yes, because whole numbers start with 0. Is 0 a natural number? No, it's not. 0 is not included in the set of natural numbers. So that is it. 0 is real, rational, integer, and whole. Let's look at some more examples. Why don't we, huh? Let's do that. Let's do that. All right. Actually, we're going to eliminate number 10. I forgot. We did not do cube roots. I don't even want to talk about that. This is bananas. But number 7 is negatives out front, so it's still going to stay out front. And the square root of 64 is 8. So we are talking about negative 8. Well, it's real. It's rational. Is it an integer? Yes. Integer. Is it a whole number? No, because it's negative. So this is just real, rational, integer. Done. All right, remember what that little bar represents over top? It represents repetition. That means it's going to repeat. This number is negative 0.123. No more decimals, just one. Let me start over. Negative 0.123, 123, 123. That's what the dot, dot, dot. That's what the bar represents. It repeats. So that should tell you, you already know it's real. All of them are real. That this is going to be rational because it repeats. And it's a decimal, so it's not an integer, so there's no sense in asking yourselves any more questions about that one. All right, last one, number 9, negative 24 over 6. Well, let's just divide. Negative 24 over 6 is negative 4. Oh, I didn't change colors. I love more colors. All right, we know it's real. We know it's rational. Now we get to ask ourselves some questions. Is it an integer? It show is. Integer. Because it's negative, I know it's not going to be a whole number, okay? And like I said, we're not going to talk about 10 because we do not do cube roots. We're not doing that. All right, so now below this part on your paper, you have this diagram here, okay? Each one of these, let me move this out of the way. Each letter here represents one of these fabulous real numbers. We're going to place the letter in the smallest subset that contains the value, okay? So maybe that's a little confusing, but let's do this together, okay? So first off, A, negative square root of 50. I don't really know what that is, but let's look at it. Negative square root 50 is negative 7.07167812. Well, yeah, I guess there's no repeating. I mean, really, look at the number on your calculator. There's no repetition. There's no pattern here. So it is in the smallest set, right? This is the reals, this big square, right? This is like the diagram we already filled out. But this number is totally irrational. So A is going to go in here. I'm done with that. All right, next, B, 3.895. Well, it is a real number, but it's also rational because it terminates. So rational is its smallest step because it's not an integer. It's got decimals. All right, 8. 8 is rational. It's also an integer. It's also a whole number, and it's also natural. So this is the smallest set that it belongs to. So I'm going to put this one down here. 8 belongs to the naturals. Negative 11 is rational. It's also an integer. It's not a whole number because it's negative. So integer is as small as I go. All right, negative 4 1/5. Oh my gosh, what's that? Negative 4. It's negative 4.2. That terminates. So that should tell you something. It should tell you it's rational. It's a decimal, so it's certainly not an integer. So E is going to go up here with B. All right, F. Remember, we talked about this before. This is pi. This is, flip your paper over. I gave you an example of where pi belongs. What subset does pi belong to? It belongs to the irrational set. So F is going to go in here. G is 1.7 repeating. It has repetition. It's a decimal. It's totally rational. All right, square root of 196. I don't know what that is. Get out your calculator. Square root 196 is 14. Whoa. Well, 14 is rational, an integer, a whole number, and even more specifically, a natural number. So I'm going to put my H right here. Square root of 0, that's weird. I mean, let's just check out and see what it is. Oh, it's 0. All right, 0 is rational, an integer, and also a whole number. Remember, 0 is not natural. So 0 is going to go right here. We're going to put I right here. All right, Jay, don't let them trick you here. There's a negative outside of this absolute value. The absolute value of negative 34 is positive 34, but there's still this negative out front, so we're still talking about negative 34. Negative 34 is irrational. It is an integer. Is negative 34 a whole number? No, there's no negatives in that set. Negative 34 is an integer. So we're going to put J right here. All right, remember, negative exponents are not happy. To rewrite them, we simply make them as fractions, so 1 over 3. Put that in your fancy little calculator. Remember, fractions are division. 1 divided by 3 is 0.333, repeating. Yes, it's repeating. It's rational. So we're going to put K up here. It's a decimal, but it's a rational one, so that's where we put it. All right, number L, 27 over 9. 27 over 9, 27 divided by 9. That's easy. That's 3, right? Go down the list. 3 is rational. Is it an integer? Yes. Is it a whole number? Yes. Is it a natural number? Can you see 3 of something out in nature? Oh, yeah, sure. It sure is. Here we go. We're going to put that L right here. That's nice. Oh, my gosh. Scientific notation. Look, it's all coming back around. 7 times 2 to the negative second power is 0.07. 0.07 is a decimal. Yes, and it terminates, so that makes it rational. So we're going to put M right here. We're almost finished with this, guys. All right, N. Remember, this negative is out front of that square root. So negative square root of 4 is negative 2. Well, negative 2 is rational. Is negative 2 an integer? Yes. Is negative 2 a whole number? No. So we better put that in here with the integers. All right, fabulous. I hope you were able to follow along. And if I went too fast, you know you can always rewind, play it again. You can save this video, watch it in your spare time. It's a good time. Don't forget to do your assignment. And if you have any questions, hit me up on Schoology.